Hello friends, you are watching Math Guru, and in this video we are going to learn what is the rank of a matrix and how to find the rank of a matrix. Before we see what is the rank, let us get aware of a term called submatrix. Okay, now what is submatrix? Let us see first. A submatrix is a matrix. A submatrix is a matrix obtained by eliminating one or more rows or columns or both. For example, let us consider a matrix 2105 3212 2113. Okay, now this is a matrix of the order 3 by 4. It has 3 rows and 4 columns. Now suppose if I remove the fourth column, okay, then I will obtain a matrix. Let us name the question matrix to be matrix A, and after eliminating the fourth column I am getting a matrix whose entries are row wise entries are 210, 321 and 221. Obviously this is a matrix of the order 3 by 3. Clear? So this is matrix B is called the submatrix of matrix A, since we have obtained this matrix B from matrix A by deleting or eliminating the fourth column. Clear? Now suppose I even remove the third column also, and let me also remove the first row. The first row and the two columns I am removing, third and fourth. Okay, now the matrix obtained, say matrix C, will be a 2 by 2 matrix. Okay, so again matrix C is called the submatrix. Here remember that matrices B and C are square submatrices, okay, uh, of matrix A. Clear? So I think now you have well understood the term what is a submatrix and what is a square submatrix. Clear? Now one more thing you need to remember is that the matrix is a submatrix of itself. Okay, so matrix A is a submatrix of itself, we can say. Okay, now let us see what is the rank of a matrix now. Rank of a matrix. Okay, here a number r, small r, is called the rank of matrix, given matrix. Okay, say matrix A we are given. Okay, if number 1 all the square submatrices of order r plus 1 or more are singular. This is the first condition. Okay, and the second condition states that there exists, now by singular what do we mean? Singular matrix is a matrix whose determinant is 0. Okay, so second condition, now let us see. There exists at least one square submatrix of order R which is non-singular, Okay, so a matrix which satisfies the two conditions is called a, in other words, if the two conditions are satisfied, then only we can say that R is the rank of a given matrix A. Okay, now let us try to understand how to find the rank with the help of certain examples. Let us consider the first example over here. Matrix A is given, which is of the order 3 by 3. Remember one thing, since we have to check the singularity or non-singularity of a matrix, we need to always take out a square matrix from the given matrix. Yes or no? Square submatrix only, because the determinants, you will be able to find the determinants of, or determinants are defined for the square matrices only. Clear? And therefore over here matrix A is a square matrix, and we know that every matrix is a submatrix of itself. So first of all we will find the determinant of matrix A itself. Okay, so let us check the determinant of matrix A. We will expand along the first row. 1 into 1 1s are 1 minus 2 2s are 4 minus 2 into 2 1s are 2 minus 2 2s are 4 plus 2 into 2 2s are 4 minus 2 1s are 2 equal to, we have minus 3 minus 2 into minus 2 plus 2 into 2, so minus 3 plus 4 plus 4 minus 3 plus 8 is equal to 5, which is not equal to 0. Okay, and therefore we will say that A is not singular. Now if A is non-singular, then the rank will be 3 only. Okay, because matrix A is a matrix of the order 3 by 3, and therefore the rank, we use the symbol R of A to denote the rank. Okay, rank of matrix A is 3. Clear? What happens if A is singular? Then we will try a square submatrix of order 2. Clear? Lower order. Clear? And then we will check whether we are getting any, at least one square submatrix of order 2 must be non-singular. Okay, then we can say that that matrix has order 2. This will be clear by the second example. Okay, here the matrix A, let us first calculate the determinant of matrix A. So determinant of matrix A is 1 into 5 5s are 25 minus 6 4s are 24 minus 2 into 5 4s are 20 minus 6 3s are 18 plus 3, 4 4s are 16 minus 5 3s are 15 equal to 1 minus 2 into 20 minus 18 2 plus 3 into 1. So 1 minus 4 plus 3 equal to 0. Okay, now see, the matrix A is singular. okay, and it is of the order 3. So now we will take a square submatrix of order 2. Okay, now how many square submatrices of order 2 are possible? Okay, so there will be a certain number of square submatrices. Okay, you get various ways. For example, by deleting the, suppose we are deleting the first row and the third column. Okay, then you will get a square submatrix. Say it is matrix B, whose entries are 4, 5, 3, 4. Now we will calculate the determinant of matrix B. 4 4s are 16 minus 5 3s are 15 equal to 1, which is not equal to 0. Okay, now since matrix B is non-singular, and therefore we will say that the rank of matrix A is rank of matrix A denoted by R of A is 2. Clear? Okay, now let us study further examples. Look at example number 3. Obviously, this is a matrix of the order 2 by 4. This is not a square matrix, yes or no, and therefore we need to first find out the square matrix by deleting some rows or columns or both. Okay, so here I can, by eliminating the third and the fourth column, I can get a square submatrix. Okay, so let B be the square submatrix obtained by deleting the third and the fourth column. Okay, so we have entries 1 2 4 3. Now let us calculate the determinant of matrix B, which will be 3 1s are 3 minus 4 2s are 8 equal to minus 5, which is not equal to 0, and therefore the rank of matrix A will be 2. Since we have got a 2 by 2 or a matrix of order 2 to be non-singular. Clear? At least one matrix of the order R, if non-singular, then the rank will be that order. Yes or no? Okay, now let us study one more example. Look at the matrix A, which is of the order, it is a square matrix of order 3. So let us first calculate the determinant of matrix A. Here, now it is very evident, if you look at the matrix, we have first and the third rows identical. Okay, and therefore, okay, in determinants we have already studied this property, that if any two rows or columns of a given determinant or given matrices are identical, then its determinant is 0. So this is going to be 0 determinant of it. Clear? So now what shall we do? Now we will find, since the determinant of a square matrix of order 3 is 0, now we will obtain a square submatrix of order 2. Okay, from matrix A. So let me obtain a matrix by deleting the first row and third column. So we have, suppose we have matrix B, this is matrix B obtained by deleting first row, third column, 3 6 1 2, and the determinant of matrix B will be 6 minus 6 equal to 0. Let us obtain some other, because we need to check that there is at least one square submatrix of order R. If 2 is going to be order, then you must have at least one square submatrix of order 2 which is non-singular. Okay, so let us obtain another matrix by deleting the first row and the first column. So you have 6 9 2 3. Okay, now let us calculate the determinant of C. 6 3s are 18 minus 18 equal to 0. Okay, let us try to obtain another matrix. Okay, suppose I am deleting the second row and second column, so I have entries 1 3, 1 3. Obviously this is also going to be 0. So what we notice, okay, all the square submatrices of order 2 will be singular, because the determinant of each of these matrices will be 0. Clear? And therefore the rank will not be 2. So what? Obviously in that case the rank of this matrix will be 1. Okay. Why? Because obviously if you take a square submatrix of order 1, then you will find that you will get at least one element, okay, which is non-zero. Okay, so except the null matrix. We know what is null matrix. Null matrix, all the entries are 0. Yes or no? Each element is 0. So if a given matrix is a non-null matrix, okay, clear, then, and if the order is not 3 or not 2, then the order will always be 1 for a non-null matrix. Clear? One more thing you will remember is that the order of, you have to notice that the order of a null matrix is not defined. Okay, clear? And the order of a non-singular square matrix, uh, just replace the word order by the rank. Okay, rank is not defined. Similarly over here, the rank of a square non-singular square matrix of order n is n only. Okay, so if a given matrix, for example, is a square matrix of order 3 and it is non-singular, then the rank will be 3 only. If the given matrix is a square matrix of order 2 which is non-singular, then the order will be 2 only. Clear? So I hope that you have well understood the concept of a rank of a matrix and how to find the rank. Okay, for further topics, keep watching the Math Guru my YouTube channel. By that time, thank you very much.